hardware problem. As the title here suggests, let's do the greatest common denominator problem. Greatest common denominator is like saying if you have two numbers, A and B, what is the biggest denominator that divides evenly into A and B? One thing I don't know about is the signage of stuff. So for example, and then because I want to see, one thing I need is like is this less than 0? I don't know if I need to explicitly sign stuff. And then so yeah, maybe this is just a 1-bit boolean. I'm curious what that'll say. It is not less than 0. So yeah, I'll use the logic assigned to do it. All right, so this one is an interesting one. And instead of parameterized inputs, let's say that. Also, another thing I want to test out is suppose can I cast it like this? Or does it need to come in signed? As an example. Yeah, I don't really play with signs much, so it's nice to know what all this does. So I can cast it, even if this isn't signed, I can cast it to signed. Okay, that's good to know. And the reason why I don't want to parameterize this is because if you have like a lot more than 15 or 16 bits, then it might take a super duper long time. And then once I write down the input parameters, then I'll say so this interface is input interface with valid ready to take A and B, and then after some cycles we'll output a result. And then so how do you approach this problem? Okay. The algorithm I'm thinking of is probably as follows. Choose between lower of A and B. Call this like your num. And then this sign num will basically say I want one more bit actually, and the reason for that is because if these are unsigned integers and the MSB is 1, I don't want it to do the wrong thing. So of particular interest is y. So this is 1, 0, 1. What is y? 0, 1, 0, 1. Okay. Okay, cool. So these are unsigned positive. So we call this num, right? So for example, logic signed num, and then so assign num equals this initial num. It might be a state thing, but just for simplicity, if it's less, then I'll choose a. Like that. And then so basically we start with a smaller number because the set of possible denominators must be from 1 to, so this square bracket is an inclusive interval like in math, to the min of a comma b. Ergo, once we set a num of min a comma b, then we can count down to 1 and just test to see if it divides evenly to a and b. Even division is separate, is checked by following, namely, first, take a minus num, and this will be vacuously true for the first num, if each cycle, if 0, then check, go to 1b. 1b is like, b is like if it's less than 0, it doesn't divide evenly, which is why we need this signed num here, and then num like this. So let's implement that. If num return result equals 1 with val out. But you could also just do the last thing if you want. Yeah, we're guaranteed if num goes to 1, it'll divide. So, and then so your worst case scenario is going to be 2 to the 16 cycles. So like, oh sorry, yeah, 2 to the 16 times 2, which is 2 to the 17, which is less than 1 million cycles, which isn't too bad. So because num will like do this -1 thing, perhaps we could do something like this if we have a handshake. Then it's like this, and then the num will be updated the next cycle of ready in. And then enum will just be idle, test lower, test upper, and then so these are all reset to 0, and then if we have a handshake, then temp A will just be A, temp B will be B. And then I basically want to assign the ready in as if we are idle. So that's somewhat straightforward. Let me leave the instantiation above and then have these instructions here so I can easily implement it. And then, okay, so next is the combinational logic. I don't really know of like a good ordered way to do it, but you know. So the next state is if val and ready, then we want to go to test lower. Otherwise, we want to go to idle. And if we are test lower, then next state is going to be if valid out, then we go back to idle. And if it's not valid out, then there's another possibility, which is temp A equals 0. And if temp A equals 0, I don't like the spacing on this, but yeah. If temp A equals 0, that means A is dividing evenly, and then we will undergo to test higher. And if we're not a valid out, actually we can't ever be a valid out because we always will test the lower and then test the upper. So So for example, if it divides evenly, we'll test higher, and then we'll keep this test lower state in test lower, where if temp A is less than 0, we're still in test lower, but we'll just do like num equals num minus 1. So that's okay. And then I'm saying this is better, so we're always making sure this is the low and this is a high, and they're all signed. So if this equals 0, it means the lower divides and the higher divides. And if this is less than 0, we need to do num equals -1 and then go back to test lower with that. And then, yeah. If it's more than 0, then we keep doing, this on temp B. Sorry, not temp B, temp low is what I call it nowadays. So this implies both have divided evenly, and then we're ready to output, and then go back to idle, and then receive the next thing. And then the temp high less than 0 means A divided evenly, but B didn't divide evenly. So we need to do we'll reset temp B and temp A, and we'll do like num equals -1 or minus equals 1, and then we'll retest A to see if it divides, and then higher to see if that divides. And then otherwise, temp high is positive, which means we'll just keep subtracting. So this can only be possible in idle state because of this. So then let's handle the test lower case. So if this is reset, and we could also do something like this. Because we always reset it, so we might as well just make it a little easier to use. Okay. Higher hasn't changed in reset because we haven't touched it. So if test lower and this is less than 0, that means A hasn't divided evenly, which means we need to reset this temp low, and then also the num is just going to be num -1. And yeah. If this is greater than 0, then this is simply this. So if this is true, we know the next state according to lines 41 and 42 to go to test higher in the next. But in case the test higher needs to drop back to test lower, we can go ahead and reset it here. So this tests all possible situations in the test lower state. In the test lower state, if we're less than 0, it means it didn't divide properly, and then temp low needs to be reset, and num equals num minus 1. And then we're still in this particular case, we're hitting this, so then we will just keep, and then temp low will be more than 0, because it's reset to the either A or B, which is positive. Then state is also going to be test lower because, you know, of this. Num will be num minus 1, so then each iteration we subtract, it will be like the GCD, we're testing GCD minus 1. And then, you know, this will kind of keep updating until either hit this case or this case. If we hit this case, we've already kind of covered it, and then num will minus 1. Num minus 1, this will be reset, and then we'll keep going. Now, if it's equals 0, we'll just go ahead and reset it in case we need to use it again later on. And we're guaranteeing this case because of this plus, this plus this. It must mean that we're going to go test higher next cycle, so then this is not going to hit, and none of these will hit in the next cycle. And yeah, so it's kind of mutually exclusive. Why is it indenting for me? Let me see if there's some compile issue here. Line 54. Line 54 again. Oh, okay, God. Too much TypeScript. And else if begin, and else if end. Oh, okay. Temp B has not been declared yet. Okay, let's clear out some typo errors. Okay, so the next thing I'll need to handle are these mutex states, because if state is higher, then we basically, I call it temp high, not higher, yeah. Then we'll basically be mutex of this. So actually can't be end else begin because we're not guaranteed state is higher in the else case. So if higher and temp high is less than 0, then that means we're going back to test lower, which means temp high must be reset, and then also num is num minus 1, because this particular candidate num didn't work out. Num really should be named divider, but I guess it doesn't matter. So every new iteration, like every new set of A, B, C tests, we don't have to do any num resetting because we'll just output the num worst case scenario, num equals 1, and then we'll output it. And then the next time we're jumping out of idle, this will be reset anyway. So anyway, yeah, this doesn't divide, and then so num is just going to go back to high, higher, higher. And because lower and higher are 16 bits, this might not be necessary, but might be good and safe. Okay. So anyway, yeah, this test higher, the second one doesn't divide, and temp low was reset already, so we don't have to reset it here. We can if we want. And num is going to be num -1. So then next time around, we actually will just hit this, and then we'll just do. Yeah, so the next state will be test lower, and then suppose where test lower, temp low is going to be some positive value. We'll go ahead and immediately test out the new value. If the next cycle is 0, then it'll reset, and then we'll go test higher. Else, if it doesn't divide for some reason, then we'll just kind of keep lowering it. So I hope this makes sense. And then the next here is if we do have this case, it means that we divide evenly. And then so what that means is we're going to go to the idle in the next state, and I don't know if we need to do anything here, because if we're going idle next state, then all these will be reset the next time we have a new set. So actually just get rid of it. And while we're here, we could just say assign val out equals 0. So if this is true, then that means this particular num is working out. And then therefore we could just qualify val out here. And then if it's bigger than 0, then it's the same case as here. Idle. Oh, I need to do the state transfer also. I believe this to be somewhat correct. So let's do and then val out. Let's just do 3 and 5 and then maybe play around with other stuff. And now just say clock is 0, reset is negative. Just kind of curious if this worked. Task, print, begin, end task. Is this how task syntax is? It's been a while. And then I care about this cycle, so maybe I'll display something this cycle and then do something like this, and then I can say I want to take a look. I know what my A and B is, so I'll just look at val in, ready in, and then also I'll look at the state, next state rather. Yeah, next state is kind of hard to look at, and then I'll look at the result, and then I'll also look at, no, I won't look at that. next clock like this, and so this resets everything, and then we also do and then val in is 1 always, so let's just do this, and then if we ever detect val out, then we're good. What are all the inputs and are they all defined? AB is defined, clock is defined, reset is defined, and valid in is also defined. So I think we are all good to test here. And then, yeah, the state machine should be able to handle Oh, we had it here. The result is 1 because they're relatively prime. And this should also result in a 1, hopefully. And then let's see if this doesn't result in a 1. Okay, cool. It is a 4, and then one thing I should specify in the spec is A and B can't be 0. Because this can't divide really by 0. Or if it's 0, then I mean, you get the point. If it's 0, you need to special case it and then just like say, hey, if there's 0, then you just return immediately on idle. Like you stay in idle and then you're like you just muck, like you would just like muck with these, and then you'd also muck with these state transitions. Like you wouldn't go to test lower if it's 0 because you can just output the result immediately. And then maybe let's try 24 and 22. This is a pretty intense one as well because 2 is the only thing. And then perhaps 16, looking for 4. Anyway, yeah, I mean, this went quite a bit smoothly. Oh, that is 8 actually. I thought the GCD would be 4. Yeah, this went quite smoothly. There's no like algorithmic bugs, which turn out to be good. The only thing that slowed me down was like my naming the higher lower stuff, like a few typo issues. So like higher instead of high, and then like test upper instead of test higher. But I think the signed and non-signed thing is like pretty educational, and I'm glad I tested out the less than 0 at the beginning. And yeah, so this is how you do this GCD problem. I would say this is a harder problem and probably would take most of the interview because as you can see, it's like not a low amount of code, and then it kind of depends on your experience with signed and unsigned. Someone who's very well versed in like the very nuanced signed and unsigned stuff might not feel the need to pad it, but then padding it and then also assigning, like just chopping off the top bit, is a little bit safer. And I might have wasted some kind of time doing it and kind of thinking like a lot of mental bandwidth and time thinking about these cases. But as an interviewer, you kind of your responsibility understand that like, yeah, they spend a little bit of time making it very safe, but the algorithm is like pretty good. I think that's all good. But anyway, yeah, that's it for this one. Went surprisingly bug-free, so yeah. Anyway, yeah, hope you enjoyed this one.